How does a router know what to do with a packet when it receives it? Where does it know where to send it? Well, let's try something out. I'm going to ping from 1.2 here to 1.3. So let's try that out. Ping 192.168.1.3. Well, that pings just fine here. Well, let's try pinging this 2.2 up here in this upper corner. 2.2. Uh-oh, it says destination host unreachable. All right, now we have a problem. This router did know what to do with this packet, the one destined for 1.3, but it didn't know what to do with this one destined for 1.2. Well, the problem here is the routing table. The routing table is a series of networks and where to send the packets. But since this router has never seen 192.168.2 network, it doesn't know what to do with that. So before we learn how to fix that problem, let's start with just learning a little bit about the routing table and what it looks like. So I'm going to open this router up, go to the command line, and I need to be in privileged exec mode, and the command I need is show IP route. All right, we have a routing table here. Let's learn how to interpret it. The first thing I have is a set of codes that tells me local, connected, static, RIP, and so on. And then I have this line that says gateway of last resort is not set. That's referring to the default gateway for this router. It's called the gateway of last resort, or the default route in the case of a router, unlike with a PC where you call it the default gateway. Now, we can set one that says, hey, if I don't know where to send a packet, send it out of such and such port. Next, we have a series of, well, looks like a whole mess of stuff here. Let's see if we can figure out what this is. First of all, it says, well, what about this network here? The 192.168.1.0 network. And notice it put a /24 here. Well, it happens to be a /24, as I noted down here. But that's not why it put it there. It put it there because 192.168.1 is the classful /24, and it's saying it's being variably subnetted into two subnets. So let's see what those two subnets are. First of all, there's the 192.168.1.0/24 network. That's this network here. And this C indicates that it is directly connected to this router. And it's connected through Gig Ethernet 02. So this is Gig Ethernet 02 right here. And it says, I know that this network can be gotten to by this interface right here, Gig Ethernet 02. That's why we were successful in pinging 1.3 down here, because it knows about how to get to this 1.0 network. The next thing it says is L, which means local. 192.168.1.1/32 is directly connected to Gig Ethernet 02. Well, what's that mean? Well, it means 1.1, that's this address right here, is local to me. I own that address, and it's a /32, which would be 255.255.255.255. In other words, this address and only this address is directly connected to Gig Ethernet 02. So it knows about the network, and it knows about the address attached to it. Now it knows about the 5 network. That's this one up here between router 1 and router 2. And it's, notice that it says 24, even though this is a /30. That's because its classful address would be 24, but it's been subnetted into a 192.168.50/30 because I only needed 2 addresses, and this is how I can get 2 addresses, the 5.1 and the 5.2. So I used a /30 for that. And it knows that 5.2, which means only 5.2 because it's a /32, is local to me. It is connected to me, and I have 5.2 and this particular address on serial 000. So this is serial 000. Now we have the same thing going on then for the 6 network, which is over here. We've got the /30. It says this network is attached to me, directly connected, and that 6.1 is the local address, local to me, /32. That address only is through serial 001. That's all that this router knows about. Notice it doesn't know anything about the 192.168.2.0/24 network. It doesn't know how to get there. And because it doesn't know how to get there, it had no way of sending that packet up there. In the next video then, we're going to look at the first way that we can remedy that problem, and that is through a static route, a manually configured route.